So, hello, dear guys. Now, let me talk about this what's called as expectation value, and we measure these expectation values of these dynamical quantities. And to be precise here, what expectation means, it refers uh, to expected most, the value that's expected most. And and if we go through the interpretation of Max Born, according to Max Born, the wave function psi that we have has it has probabilistic interpretation, and we can calculate its probability by taking its complex conjugate. Therefore, it's essential to calculate the average, or or what you call as expectation value, the average or expectation value of a dynamical quantity. And now, this dynamical quantity in physics, it simply refers to, say, for example, it refers to space coordinates. It refers to momenta. It refers to energy of a system. So, what we have uh, is that we want to calculate this average. We want to calculate this expectation value of the dynamical variable that's involved, which has a wave function associated with it, and 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 this wave function has probabilistic nature. It has probabilistic interpretation. Now, if we have to define this expectation, this expectation value, I should say that it's basically the average. You can call the average value of a dynamical quantity. The average, or you may use a word now, the expectation value of a dynamical quantity. And what is it? It is the mathematical expectation of the result of a measurement single measurement. So, what is it? It is basically the mathematical expectation of the result of a single measurement that's carried out. And we can also say, we can also define it as the average of the result of large number of measurements, a large number of measurements on independent systems, where we have independent systems, and we can have an expectation value of all those independent systems. Now, to have the mathematical interpretation of this expectation value, now if I assume that uh, I have a dynamical variable, say that is a, and I want to calculate it's a dynamical variable, and an operator associated with this dynamical variable is a cap. So, if I have to write down the expectation value for this a, that expectation value is defined as the integral of probability density times the operator that's linked with this dynamical quantity, say a cap, then t top. So, if I write down this probability in terms of the wave functions, it will be psi star, say r and t, a cap, psi, r and t, d top. So this equation is going to give me the expectation value of the dynamical quantity which I assumed here as A. And this A is the dynamical quantity, and A cap is the operator that's linked with this observable, that's linked with this dynamical physical quantity. Now, so I would like to generalize this thing. Suppose I have to write now expectation value of position, expectation value of position, and assuming that position to be R. So what will be its expectation value? It will be integral psi star R cap psi dr. Now, if I take it over volume, then I should go with d tau. So this thing can be equivalent to the expectation value along x, along y, along z. So we can write down the expectation value for position. We can write down this expectation value for position as, say, if I have x, the expectation value of x, it should be integral of psi star x psi dx. And similarly, I can write down the expectation value along y. That is psi star. Now here I missed the cap because here I don't have exactly the position. Here I have the operator that's linked with this position. So this is psi star y cap psi dx. Similarly, we can write the expectation value along z as psi star z cap psi dx. That should be the case. Now, what are these x? What is this x, y, and z? These are the expectation values. These are the expectation values of the coordinates. This is the expectation value of coordinate x, along y, along z. In the similar way, if I have to write down the expectation value of, say for example, potential energy, expectation value for potential energy symbolized as V. So the expectation value of this potential energy will be integral psi star V cap psi d tau, where this V refers to the potential energy, and the bracketed overall term is the expectation value of this potential energy, and this can be calculated by taking an integration over this probability enclosed by the operator that's associated with this expectation value, is associated with this dynamical quantity. So in the similar fashion, suppose I have to calculate the expectation value of energy. Suppose I have to calculate the expectation value of energy. So what will be the expectation value? So I have energy, the expectation value of energy, and I have integral, I have psi star, and I should write the operator corresponding to energy, E cap, psi, then d tau. So this will give me the expectation value of energy from this point of view. And if I have to use the value of, suppose here I will use the value of the operator that I have for energy, right? So I can write down this as E, expectation value of E is it is psi star. So for E, I have an operator, and for E operator, what I have is IH cross. This is time dependent operator, then dou by dou T of psi d tau. Right? So the energy of the expectation value of energy will be integral psi star IH cross. I can keep it out, then dou by dou T, dou psi by dou T d tau. So this is gonna give me the expectation value of energy. Now, in the similar way, we can go for the expectation value of momentum. So momentum will behave as a dynamical variable now. So I have the momentum, and what should I write is integral psi star. Then the operator that is corresponding to this momentum is p cap, then psi, then d tau. Right? So this is gonna give me the expectation value of momentum. And I can write down the operator that corresponds to this momentum and write down that operator here in order to calculate the overall expectation value. So moving on from here, so I can write down here that P is integral psi star. For momentum operator, what I have H cross by I, then I have del times psi d tau. So this equation, when we're gonna evaluate this equation for the wave function that would be there, all we have to do is to calculate this integral, and I will be able to calculate the expectation value of momentum. And I can write down the expectation value of momentum along x. I can write along y. So along x, it will look like psi star H cross by I. Then here I will have dou by dou x, dou psi, then dx. So this will give me the expectation value along x. Then I can write along y, and I can have this H cross by I out, and I can have psi star dou psi by dou y dx. So this is going to give me the expectation value of momentum along y. And talking about z, this is H cross by I integral psi star dou psi by dou z dz. All right, so this is it. So what we have the expectation value for momentum. So the set of these equations that we have, they give us the measure of what? Expectation values of the components of the momentum along x-axis, along y-axis, and along z-axis. Now, one thing is important at this point, which I'm supposed to tell you, is that that above formulas, that the formulas that we have here, these formulas only hold when we have the wave function which is properly normalized. So these equations are completely valid for wave functions which are completely normalized. And we better understand what's normalization. Now, if we have a situation where we have not a wave function which is not normalized, then we can write down the expectation value for this dynamical quantity, which I had chosen as A. Its expectation value can be written as integral of psi star A cap psi d tau by integral psi star psi d tau. So if your wave function is not normalized, then if you have to calculate the expectation value, in that case, you will have this equation for the calculation of expectation values. So I should say that if the wave function is not normalized, we have to use this definition that's given here to the expectation value of this dynamical quantity of whose wave function is not normalized. And if whatever I have shown you till now in terms of energy, position, and momentum, if the wave functions linked with those dynamical variables are not normalized, then in those cases, to calculate the expectation value, you have to make use of this equation. And that should be the case. So this is what I have for you. Whatever I feel and whatever I have learned, I'm trying to share these things with you so that maybe there is some kind of benefit to somebody out there who is just watching these videos. And I request your good selves that if you find these videos fine, you like them, you share them, and and you subscribe the channel so that I find more interest, so that I can make more videos wherever I feel that I can have an introspection where I feel I can deliver, I can give you the ideas, and those ideas may help you, and you may work with those ideas. So with this, I would like to end this video.